So, hello friends. In this editorial, we are going to discuss about our Leetcode weekly contest 405. So, basically, let's talk about the first problem statement. It's an easy level problem. Let's read it. You are given a string s and an integer k. Encrypt the string using the following algorithm. For each character c in s, replace c with the kth character after c in the string in a cyclic manner. Return the encrypted string. Okay. First of all, let's talk about the problem statement. You have been given a string s. Okay. String s like any of the word containing 4 to 5 characters or 6 character also. And an integer k. Okay. And an integer k we have been given. So we have to encrypt the string using the algorithm. We have for each character of c. For example, you have been given like a character like string. Yes, you have been given a string named string only. So what you have to do basically here? You have to change the characters. Okay, you have to encrypt it. Means replace the string means the characters with the kth character. For example, your k is here 3. So for from C from the our C is what S here. Okay, so at the third position at k equals to 3 we will change S with I. Okay, so our S will become I. Okay, then next. Then we are going to string T. Then three characters. Okay, then N. We are changing T to N. Okay, is that clear? Then, then we are going to where? Wait a minute. Huh. Then we are going to R. Then we are going to R. Then three characters later we are going to G. So R is changed to G. Okay. Then we are going to. Then comes a what? Then comes a change here. We are now at I. So we are there are only two characters only, but we want to change three characters. Okay. So how come we will get? We will use in a cyclic manner, as you can see in the problem itself, in the left side of it. In a cyclic manner means the cycle will run like this. The cycle will run like this. Wait a minute. Yes, Tring. Okay. So our cycle will be yes. Is Tring. Okay. So our cycle will go on running and running till we get on to the last character, which is G. Okay. Till we go on to our last character, which is G. Our cycle will be running and running. Okay. So our string is at I. Our pointer is at I now. So after three character, it will go on S. Okay. So our I is changed to S. Okay. Is that clear? Then, then next one. Then our pointer is at n. After 3 characters, it will point at t. So our n will change to what? T. Okay. Similarly, there comes the last one. Our pointer is at now G. After 3 characters, it points towards R. So our G is changed to what? Our G is changed to R. Okay. As you can see here. So basically our new string, what will be our new string will be I N G S T R. Okay. So this is basically a new string. Okay, I think you must have understand the question. Okay, let's try to understand it with the more types of examples like Dart. Okay, like let's understand it with Dart. So basically, you have been given a string called Dart. Okay, and K is here what? K is here what? 3. Yes, so our K is here 3. So basically, what will be the answer? Our pointer is now at what? D. So after 3 characters, it will point towards what? T. So our D is changed to T. Okay, let's make a circle here. D A R T. Okay, so our D is changed to T. Next our pointer is at what? Next our pointer is at A. Okay, so after 3 characters, it will points towards what? D. Okay, after 3 characters. So A is changed to D. Okay, next. Next is what? Next is R. Our pointer is at R, so after 3 characters, it will point towards A. Okay, so R is changed to A. Is that clear? Then after R, there comes T. So after 3 characters, we are at R. Okay, so basically, our T, our T is changed to what? R. Okay, so our new string is what? T D A R. So as you can see, we have got our new string as TDAR. Okay. So in this cyclic manner, we have to run the code. So basically, which kind of approach you will use here? What approach you will use? Okay. It's a question. Okay. What approach we will use here? So basically, we will use a simple algorithm. Okay. Just we will replace the string S, means the character C in the string S. Like for example, our character C is D. Okay, we will replace it with the kth character after C in a cyclic manner. Okay, this cyclic manner. Okay, so what steps we can achieve the expected output? We will iterate through each character in S. Okay, then determine the index of the character and calculate a new index after moving k position forwards. But the main approach is what we will use modulo function. We are going to use modulo function. Okay, wait a minute. We are going to use here modulo function. So in this modulo function, and what we are going to do? This modulo function and is a very unique function. Okay, we think that these are used for 2 mod 3 equals to what it gives 2, just for finding this only. But it also performs the cyclic operations also, the modulo function. So let's see how it performs. Okay, so first of all, let's understand it with the help of code also. Okay, Let's understand it with the help of code also. So first of all, let's see. So basically are taking R as our encrypted chars. We are taking our encrypted chars as our empty list, okay, and we are running the for loop from 0 to length of the string, okay, and we are taking new index, okay, we are taking and appending the chars of s of new index, okay, d is equals to join of, okay. So basically what I am trying to say, okay, basically what I am trying to say is here we have now created a empty list called encrypted chars, okay. I've created an empty list called encrypted chars. Let's zoom it. Yes, okay. So as you can see that I have created an empty list called encrypted chars. In this list we will perform some operations. So for example I am taking ec as our empty list, okay. So basically we are running the for loop. For example, let's take Dart as our example. We are running the for loop. Okay. So for I in range length of s from 0 to our length of Dart is what? 4. From 0 to 4. Okay. Means 0, 1, 2, 3. It will run in this order. So basically what? Basically at 0 index means at I equals to 0. Okay. Our new index will be what? Our new index will be I plus k mod of length of s. Why I'm doing mod of length of s? Let's see. I equals to 0 and k is what? 3. And mod of length of s is what? 4. Okay. Length of s is 4. Okay. S is what? String. Okay. Our Dart. This one. Its length is what? 4 basically. Okay. So 4 is the length of the string. So 3 mod 4 is what? It gives us 3. Okay, basically 3 mod 4 gives us what? 3. So we are appending the new index. Okay, s of new index. Our index is what here? This is our new index. New index is what? 3. Okay, so basically DART. So our new index is 3 here. Okay, so it will append the new index s of new index in the encrypted chars means our encrypted chars will have now T as our first characters. Okay, T as our first character, then same at I equals to what? 1. There comes a now a twist. Okay, at I equals to 1. I equals to 1, what is our character? A. So 1 plus 3 mod 4 is equals to what? 0. 4 mod 4 is equals to what? 0. So our new index is what? 0. Okay. So the character at 0th position is what? D. Okay. So we'll append the S of 0 in the encrypted chars. So our new character is what? D. Same for now I equals to 2, it will append what? It will append A. Okay. And for I equals to 3, it will append R. Okay. In this manner, this will run. And now we have got our encrypted chars as TDAR. Now we are using this join function. Join function toward TDAR. Okay. After joining, this will become TDAR. Okay. This will join the remove the commas means separations and join the function. Okay. And after that, we will return D. Okay. So this was the simple explanation of our easiest question of the contest. Okay, this was the explanation. So now let's try to submit the code. It's giving some compile time error. Def encrypted string line number 9 char D is equals to encrypted chars. Okay, there's some error here. And I have created a list of encrypted chars here basically. Okay, so now let's see what's there in the ink. I've created a array of means a list of encrypted chars. Okay, then I have run a for loop. Okay, then I have created a new index of called I plus k length of s. Okay, then I am appending encrypted chars dot append the s of new index. Then we are doing d dot join of encrypted chars and then returning d. Error expected that error class name. They are expecting us the class name. What they are expecting the class name here? Get encrypted string. Yeah, everything is fine. Let's make it friends. Let's reduce the size to R. Okay, this is I am making R. Let's make this new index to B. I plus K length of S. Then I am making it R. R dot append B. R dot append B. Then D is equals to join of R. So I am returning D. Let's try to run it. We have attended to the again it's giving compile time error strk int. So basically what kind of error is giving it? I'm not getting. Wait a minute guys. What kind of error is going on here? Let's try to sort it out one time. Okay. Where is the next font? So basically here is the, yeah, as you can see that everything is fine here and it's running as simple. What happened it earlier, I don't know. I think it must be reloaded. Okay, let's try to submit it. Yeah, it's being accepted. Okay, it's faster than 100% of Python 3 online submissions. Okay, so it beats 100%. Okay, so our next problem, let's move on. Generate binary strings with adjacent zero. Okay, so basically, this is our next problem. Generate binary strings without adjacent zeros. Okay, so let's read the problem statement. It's a medium level problem. Okay, it's just basically a medium level problem. So we have been given a positive integer n. Okay, and a binary string s is valid if all substrings of the x of length 2 contain at least one character 1. Okay, at least one character 1. Okay, then what we have been given, return all value string with length n in any order. Okay, let's move on. Okay, for example, we have been given a positive integer n. Okay, n is the length of substring. It's the length of the substring basically. So what we have to do? We have to return a binary string x. Okay, a binary string x, and it is valid. Okay, the binary string x is valid if all substrings of x of length 2. Okay, if all substrings of length 2 contain at least one character 1. Okay, means, for example, let's understand this line. Okay, a binary string x is valid. What is a valid substring? Basically, yes. What is a valid substring? Okay, a valid substring is what? Which contain at least one, means 0, 1, 0. A substring is of length 2. Keep in mind, it is of length 2. Okay, so for length 2, it must contain 1, at least 1, 1. So it is containing 1. So it is also containing 1. Okay, it is also containing 1. Let's suppose 0, 0, 1. The string of length 2 is not containing 1, but it is containing 1. So it is not valid. Okay, then comes 1, 1, 0. It contains at least 1 and it also contains at least 1. Okay, then 1, 0, 1. It also contains at least 1 and it also contains at least one character of 1. Okay, then comes the another approach. Okay, if the one appears in if the character of if the for example, if the length of the string is more than 3 or equal to 3, okay, and one appears at the left side or at the right side of the string, so it is not valid. Okay, it's just not valid. So basically in such problems, what we will do in such kinds of problems, what kind of approach we will use? Okay, it's a question of problem only. Okay, so basically we will use a generative approach. Okay, we will use a generative approach in this problem. Okay, so basically wait a minute. So guys, okay, in this problem what we are going to see? Okay, so basically we are going to use a generative approach. Okay, we are going to use here a generative approach. We are creating a list of characters. Okay, we are just creating a list of characters. Is that clear? And in that list, what we are going to do? In that list, what we are going to do? Just a simple thing and nothing else. We are going to first of all check that if the length of the string is less than or equal to the another string. Okay, if it is less than or equal to the another string, we will just generate the new function. Okay, we'll just generate a new function. So now let's see the problem. Okay, so basically the what we have been given here, let's see. So for example, our n is basically 3. Okay, our n is basically 3. So we will check for each character from 0 0 0 0 0 1 0 1 0. Okay, 0 1 0 0 1 1 and 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, so these are basically the characters containing in the three in numbers. Okay, these are the characters containing three numbers. Is that clear? So first, so we will check for this number. Is it valid or not? So basically, as you can see here, that the 000 is not valid. So in this, no one is there. So it is not valid. In this also, no one is there. So it is not valid. In this, a single one is there. In another also, single one is there. So it is valid. This is also valid. This is not valid. Okay, this is also valid. This is also valid and it is also valid. So we have got our valid examples 0 1 0. Okay, 0 1 1. Then we have got 1 0 1. Then 1 1 0 and 1 1 1. Okay, so these are basically our valid examples. These are valid strings. Okay, and we have to run. We have to generate a strings till end of the chars. Okay, means the length of the uh, characters strings. So basically, this is a backtracking approach. Okay, it's a backtracking approach. Okay, now let's see. Uh, First of all, we will create a valid strings function. And let's see the coding approach. Yes, this valid string approach calls the n as our int, and we have to return a answer in a list function. Okay, we have to return answer in a list function. So now let's solve the coding approach. Okay, first of all, we will create an empty list called result. We will just create an empty list called result. Okay, so this is our list, and call we'll call a function generate result. First of all, let's create generate strings. It will contain the self, comma result, comma empty function, then n, and then -1. Okay, so these things it will contain. Let's make it more precise. Okay, cell, let it contain SB. Okay, it will be more easier for you to understand. And let's make it last char. Okay, last character. So basically, the result is a list. Okay, the result R is a list to store the final valid string. Okay, and SB, as you can see, it is a string builder. Okay, object to build the current string candidates, and n is the desired length of final string, and last char is a character 0 or 1 appended in the previous recursive call. Okay, so basically, if the SB length means SB dot length, okay, reaches the desired length n. Okay, is that clear? If the length of the SB means length of the SB is equal to n. If it reaches the desired length n, okay, so what you will do? It means that the complete candidate string is built. Okay, so the string is added to the result list, and the result backtracks. Okay, so r dot append. Okay, r dot append. We are joining the string. R dot append join SB. Okay, and then we will return from the function here, as you can see. Then, then we will our base case has been completed, that valid string. So our next function is to add one to the string. Okay, now we are adding one to the string. Okay, so the function appends hence one to the SB. Okay, means it calls generate strings recursively with the updated SB and last char. Okay, so this and the last char is set to 1 since the newly added character is 1. Okay, so this explores the possibility of adding more characters after that one. Is that clear? So let's append SB dot append. I have appended the 1 here. Then we will call the generate self dot generate strings, and result is, and we will call here result SB and 1. Okay, as you can see, and then we will just pop out the function. Okay, then what we will do, we'll just after the recursive call means we will remove the appended one from SB using the delete char at. Okay, just we will pop out. Okay, SB dot pop. Done. So we will now add 0 to the strings. Means only if the last character was not 0. Okay. If the last char means the last character is not equals to 0. Okay. If it is not equals to 0, we'll append. We will append the 0. Okay. And now we will generate. We will generate strings. Okay. And add 0 to it. Okay. As you are able to say, we will add 0 to it. And then we will pop out the function. We will just pop out the function. Okay. Then what we have to do, we will call the function. Okay. We will just call the function here, backtracking function. We will call out the backtracking function here and just return the result. And we will just return the result here. Okay. So basically, what is the backtracking logic? The logic behind the backtracking means it explores the possibilities of all adding ones and zeros. Okay, when allowed at each step. Okay. For example, if a string is at I equals to, let's suppose, more precise. Yes. If a string is that I equals to 0, means it contains 0. Okay. So the logic behind the backtracking function is if it is 0, we will add 1. Okay. We will make it 0, 1, 0, 1 like that. Okay. Like this we will make. If we will add on going on add zeros and then ones, so this will not work. Okay. Only some of the functions will work, but the main function will not work. This will work this. Okay, so the whole is content invalid. Okay, so this was the logic behind the backtracking function. Let's try to submit it. First of all, we'll run it. First of all, this overall code, okay, uses the backtracking systematically. Okay, it's giving some runtime error. Len of SB not equal to. It's giving syntax error. If I have not used if statement here. Okay, let's try to now run it. Solution object has not generate strings. It is giving error to the generate strings function. Okay, let's try to debug it. We can also use the another approach also, like for example, if we just So for example, if our n is equals to 0, we will return the empty string. Okay. So if our n is equals to 1, what we will do? We will return either 0 or either 1. Okay, then we'll create an empty list called result there, and then a previous list. We'll create a def function, recursive function called generate strings, and we will add length. Okay, I have added here length. Okay, so if our length is equals to 0, if our length is equals to 0, we will return. Okay, then if our length is equals to 1, we will also return the empty list. Okay, containing the empty function. Okay, then we will create a result list called result here and a previous. Let's suppose let's add it here only, and a previous generate strings of length -1. Okay, then for each character in previous, so for each s in previous, if s of if the last element of the string is equals to 0, if it is equals to 0, we will append the string plus 1 in the result. Okay, and else if it is not doing so, we will just append the string with 0. Okay, I have done. Then again we are appending the same thing. Okay, then we will return the result. Then we will return generate strings. Generate strings of n. Let's try to run the code. Return. Yeah, it will run now. Yes, it's giving the correct output. Let's try to submit it. Yeah, it's being accepted. So now let's move on to the last problem.